Good morning.
Hey, good morning, students. How have you been?
Good morning.
Good morning. How have you been, guys? I see there are few new students, which is Kamran Shukurov and Kahraman. Again, I never heard of him. So, shall we get started, or shall we wait for the others as well? Whatever he has given a note that he's gonna be late, but if you guys don't mind, mm, we can get started. But first of all, before we start, I would like to give you some key and ask you, what have you done at your midterm to start off with the Yunus? Uh, I've seen your marks, and all of you guys has been failed.
This is
And
out.
yeah, but I didn't expect from you that, of course, Yunus. But
Mhm.
why did you? I mean, why did you get failed, or did you copy the answers from someone else?
No, I don't know. Maybe my answer. Firstly, my answer is intact because I misunderstood the question. Firstly, and secondly, maybe I understand it similar. Other maybe for this plagiarism was like for this.
Okay, but on your results, I seen that they found the plagiarism
Mhm.
of your answer. Maybe you copied, either you copied from someone or copied
No,
from the internet.
no, I haven't copied.
Yeah, but they say, I mean, they mentioned that you have copied from someone, and I didn't expect from you that
Mhm.
because you've been active on the class and you were you could understand everything.
No, it was. Understand the topic, and maybe I'm reading from any information before the midterm exam. I'm reading from any information internet. Maybe for this is and maybe for this reason it's a plagiarism, but I have like answer like the internet, but I didn't already.
But they mentioned that they found the plagiarism from your answer. But
Yes.
it's impossible that they could just lie and just say that you have copied from the internet. But anyways, I didn't expect that from you. The only person that who really got his mark was Waldemar and Afror. Afror. His name was either Afror or he never attended my class, but he got the mark at least. The same with Waldemar. There are only two guys that really got the mark, at least uh, by their own. You know what I mean? Yeah. So Waldemar is coming as well. I've asked them to check your.
Good
Uh,
morning.
good morning, Waldemar.
Good
How are you?
morning.
Good, thank you. How about you?
Good, good. Everything is going good, but I was just scolding you guys because of your midterm marks. Completely wrong was failing. The only person that who really got their mark was Afro and Vladimir. So the rest of them were plagiarism. If you have seen the marks on the Orpus or Opus, what you say, I mean, how do you call it? But I'm kind of disappointed from you guys. Not from Vladimir, maybe, because he earned his mark, but the rest of you guys have copied from either from the internet or from each other. So I asked you guys during the class if you don't understand or if you have any question, you may ask me, or during the midterm as well. I mean, when you were doing, you could just message me or give me a note before ahead. If I'm gonna be needing you, being ready, please, you're gonna help me. So he was like, you didn't message me, you didn't ask me anything during your exams. But what I'm asking is to do well on your final exam. But overall marks, I think it's great that you can pass at least, pass the semester. I mean, because I've been speaking to Cameron as well, but his overall mark was pass. But even though, guys, it's not fair for not for me, not for you as well, because I've been trying to teach you everything, and I've been trying to, I don't know, I've been trying to teach you something. At least you could do something. You get what I mean? So I was like, when I got the marks, I got the call, and the lecturer said, "Oh, all your students has been failed." I was like shocked. So I was like disappointed at you guys in the end, and I saw only two students that without they passed their marks. I mean, they got the marks without the plagiarism. The rest of you were like either one didn't attend the class, I mean exam, but the rest was copying from each other or from someone. So it's not fair, guys. I'm disappointed. You can't do that to me because you've been getting the good marks and can everyone hear me, by the way?
Yes.
Because
Yes.
I feel like that I'm talking to myself. Can you turn on your camera? All of you.
Oh, I just a minute.
How about the rest? Still waiting.
Just a second.
So am I gonna be waiting forever? Okay, I still got two guys left, Kaman Alim Kuluf and Khaf Rahman. So I cannot see you guys, but I'm not sure you can hear me or you can understand me at least. But I'm gonna mark you as not in the class. Anyways, if we can get started, I already told you that I'm disappointed at you guys, but you have to try harder, I think. And let's skip to today's topic that we're gonna learn. Oh, today's topic is gonna be image processing and analysis, acquiring a new information about the image. But I think it's not new information for you guys, but it's the name of the topic. But anyways, so it's a new information about the image. So we're gonna learn about image processing to the images and noises, noise reduction, and segmentation. So how does it gonna be and how does it gonna look? Anyways, the image processing, image quality enhancement, contrast enhancement, and it's gonna be noise reduction and external action. So we have another type of the image processing is image or scan analysis. So it's edge detection, segmentation, region explanation, and external action. So we're going to talk about all about that for today. So if you remember in our last lecture, which is on last Tuesday, I explained you guys how the eyes is going to protect the colors. So on the left side, you can see is how the eyes is gonna get image what you get. So it has so many skins of the how can I say lens that you can see but you can't see. So it's called the separate name. Separate part has a separate name. So in order to get so many like thousand or million colors at the same time. So you get the eyes and you get the skins and you get the lens of the eyes that we can get the clear picture. But on the right side, how the computer sees it. So you get the blue, green, red, and black. But it's called SMIC, but it's not the SMIC, but it's RGB. So red, blue, and it's gonna be black. But sometimes when you play it with red, you can get the green, but it's not matter. But it's always gonna see the three colors only. Okay. So image distractions is gonna be how you look. It's how can I say in each pixel you get the square point, right? So you get each square point 1 pixel. But it's not going to be just 1 pixel, but this is how the computer is going to see it. Okay, the image on the computer, but it's not the news for you guys. I think you do know how the image on the computer is going to calculate it, right? But
Yes.
yeah, but take in mind that these questions might be on final exams. I mean, like when I was when I started to teach you guys, I've been asked to fill up the what was the name of it? I forgot. Competency table. So what students can do, what can't do. I mean, like I've told them that you can do all from all topics that have been explained. So that's why maybe they were like uh, confused or something. But after your midterm, we were having 4 classes. So at least I'm gonna ask you guys to open up and practice at least 5 classes. I mean, like we open up to study it, uh, to study it. I mean, like um, get the tips. You get what I mean? So it's gonna be on your final exam as well. I'm not gonna be sure what's gonna be the questions, but I'm giving you a bit tips. It's going to be make your life easier at least somehow. All right. So it's not the news. Back to the topic, I mean, it's not the news that how the computer is going to calculate the pixels on and the colors itself. So you can see on the left side, it was like back in 90s, I think it's 80s. The picture was something like the small, the first on the left, something like that. But when you zoom in, you get the pixels, right? But time goes on and goes on, and it's going to be a new century. On the right side, the image on the computer is getting a different color. So it's going to be a more smooth and more pixels, all right?
Okay.
So how the image is going to calculate on the computer at the background. What you see on the left side is on the front side. What we soon will see on the monitor, and what is going to be stored on the computer is you're going to get the 1.0, 0.1, and 0.9, and 6, and so on, so on, so on. So when you see letter A, let's say on your computer, but in the background, you will be getting a coordination of the A, like starting from the pixel 1 to pixel 100. Your internet connection is unstable.
Oh,
You
we
guys
can hear you
can hear me,
properly.
right?
Yes, yes, yes.
Okay, okay. So this is how it's gonna look on your computer as your background, but on your front end, I mean, like on the front, you are getting an image, but it's calculating you the algorithm of the image. So when we get the output, you remember when we were getting the output, so it's kind of the drawing, the circle, the algorithm of the circle. So this is how what we are getting at the front on the left side. But on the right side, we're getting it at the back of the computer, I mean. So this is how what you're gonna get, all right? An image process. So every bit has every pixel, and every color has every bit colors. Okay. When you get the 1 bit, you get the 2 colors. So when you get the 2 bit, you get the 4 colors. So it's gonna be so on, so on, so on. So I would like to ask you guys to screenshot it, remember to write it down, copy it down, or something. You're gonna get this question on exam. Might be, it's not 100% sure, but it's gonna be like 50 to 50 chances that you're gonna get these questions as well. But I'm gonna give you a little tips as well and some links in order to restudy it before your exams. So your exams are gonna start on 21st of December. Well, until when I don't know, but they told me that they are planning to conduct exams starting from 21st December. So this is how your image is going to process by bits and by colors. So when we are saying that I have a 32-bit processor, so it's not your processor that is going to give you a picture, but it is actually processor what's going to give you a picture. So it's going to give you more colors and more images that you are working on your computer. Okay. Uh, Moving on, noise reduction. So when we are seeing on the top of the picture that we're getting the clear photo. But when we see on the left side on the bottom, we're getting the noise reductions. Okay. And this is how can I say several generation of the purpose algorithm and techniques that have been developed by image, and it's going to be it's a segmentation of the noise reductions. So typically, it's going to combine with the domains and specific knowledge of in order to efficiently solve the domains and segmentation problem, right? So, but on the right side, we can see how the calculation is giving us the colors and the picture by nodes. I mean noise. Sorry for my pronunciation. I have something on my mouth. So sometimes it's getting difficult to pronounce words. So we're getting the noise on the picture by using the noise reduction, and we can say that this is not going to be easy to uh, clear the noise reduction from the picture itself. Okay, so how the noise reduction is going to work? We can see the formula on the right side. We are getting the p by x-axis and y-axis at the middle of the our table. Okay, it's calculating. It's giving us the how we're gonna calculate the uh, noise to reduce the noise. Okay, and remember the formula. Write it down, screenshot it, restudy it, learn it, and I don't know. Just remember the formula as well. Okay,
Um,
and
yeah, I'm
okay.
sorry to interrupt you. I have a question.
Mm-hmm.
So, like, if there is a current, like, if there is a certain algorithm for the noise, or I don't understand. Is there an algorithm for the noise, or it just appears like I don't know, spontaneously, mystically?
There is going to be an algorithm for the noise because you see when we are seeing the picture, just let's say when we open the picture, right? But we have some parts that uh, it's not the error, it's reduction. I mean, like it's error on the picture, but it has to give you the error of the picture, right? When you start shooting from the camera, you have some parts that is broken. I mean, some pixels are broken, right? You cannot get the clear picture always, but some parts is you know, broken pieces, right?
Oh, okay.
Yeah. So that's why you will need to know the at least, for example, when you're coding a website or when you're coding a front side of the design, let's say, just take it. But you want to get to the point where exactly the point that you want. You are getting a noise by pixel, right? I mean, it's called the noise, but it's not the noise itself. I mean, like you will not do the noise by yourself. I mean, by prediction of yourself, but you are you want to get to the point when I showed you on the screen. I mean, like with the arrow, right? You will need to get the algorithm itself to get to that point to fix it or to make it error. Either one of it. So where x-axis and y-axis are currently in pixel, so an m is going to filter you a size of 3x 3y. Okay, when you see it on the, let's say like it's going to be not 3x and 3x, but maybe 10x and 10x, but it's going to be a 10x, 10x exactly, maybe 6 to 6 and 7 to 7. So when it's an I-axis and J put this element of indicates, okay? So it's something like, how can I say it? Something like you're not doing it on the purpose, but you have to do it. So it's when people in a figure are a segmentation of the as one object and background is another object, okay? Is an approach of that infidelity for every pixel. So it belongs to instance of the object that it detects each other and each distance by the interest of the image, maybe. But who knows? Maybe you will have to do it on purpose, but to get to the point. But you still have to know the algorithm of the how it's gonna work. I mean, like you know what I mean. Okay.
Yeah. Okay.
So
Got it.
okay, this is a noise reduction. So noise reduction, we already got the noise, not noise reduction. Yeah, we already got the noise, but we have to uh, fix the fix the noise, right? I mean, like we got the error, but we want to fix it. So how are we gonna calculate that? If you do understand the formula itself, it's gonna be easier. Oh, by the way, I have a question. Last time, I gave you guys a homework. Did anyone, I mean, have tried to do it?
Tried, not
Does
really
anyone?
tried. I tried to understand the algorithm that you explained, like the way it works, because you explained to us the formula and like there wasn't, let's say, like or was there like a full code, or even if there was, I didn't really understand it. So like for example, the define, where we had those arguments, I mean not arguments, functions that are like edge or sharpen, something like this. I didn't really get it how it works in the program itself. So when we run it, I got to
Mm-hmm,
calculation of the coordinates, I mean of the, like what is it, from the pixel, the coordinates of the pixels, I guess, like
mm-hmm,
each
mm-hmm,
pixel and the representation of their color, if it should be
mm-hmm,
like
yeah,
that.
yeah.
Yeah, I got
Mhm.
this, but like how, why are we using exactly those functions and how they work, I didn't get it. And I tried searching through the internet and I didn't find the meaning of all of them. So like
Mhm.
still at work and understanding this. After I think I can do it till tomorrow and I'll send you the homework.
It's okay. Anyways, we will have one more class in next week. We're gonna practice the whole topics that we have passed, starting with Graham line until the image processing. I mean, we have only 6 lectures and 6 tutorials in order to for you guys, not only for you, but you already got the idea. I mean, like idea of the programming of the C at C sharp, but how about the rest? I mean, like, I would like to help the others as well to pass the exam. Maybe you will be able to help me out here because at least you have. I saw the results of the midterm, and you and her were the only one who got their mark by their own without a reason, but the rest had the reason. So actually, the rest, I mean, the rest of the guys got me disappointed. So I would like to check our next class for the practicing. If everyone can join, it will be good. But if they can't, then up to them. Anyways, you can do that. Actually, it was not completed by me. I just deleted some parts, like few lines ago, in order to make you guys a bit work by yourself and practice more. So it was not completed, but I will tell you or show you in the next class, and will finish it. All right.
Okay.
And I gave you the second homework as well. It was a task actually. Have you tried to figure it out? I mean, not only you, but how about the others?
Which one exactly?
That
We
was
had
on.
this, like to change the program from the PPT file, and
Yeah,
the other task.
we had the we had two homeworks. I mean, one was done by me, but it's not completed. The second was in the last slide.
Oh, it was
Uh,
about the edge handling, right?
yeah,
Uh, I didn't look at it yet.
it's all right. We're gonna cover it on our next class. But just take in mind that maybe I'm by next week, but remind me that we practice
Um. Oh,
tomorrow.
okay.
All right. Okay. Golden pixels value is sum of the filter and F and image part of the A element multiplication by is, is then driven by K. So how can we understand that? I mean, like, how can we get that? A completion of base of method um, postulates that the optimal segments of the image that minimizes the overall possible segments of the coding. Okay, when you see the algorithm and calculation of the noise reduction and pixel values, and we get the filters. I will show you the filters. But if you ever have opened up the Photoshop, you get filters. I mean, automated filters. You get the noise reduction,
Yeah.
making noise. Yeah. Oh, okay. Hold on. Your voice is like bullet to my ears right now. Give me a
Oh,
second. It's okay. It's okay. Because I'm using a headphones.
I didn't mean to. Okay, I'll
No, no,
speak
no.
a
It's
little
alright.
bit.
It's alright. No, no. It's alright. It's alright. It's not. It's not your fault. It's my fault. Can you speak up?
How do you hear me? Doesn't it
Yeah,
hurt
it's
your
better now.
ears?
It's
Okay.
alright. It's alright. Thanks. It's my fault. I make apologize. A big apologize. Okay. So what were I? So if you see the noise reduction and pixel completion of the algorithm by FNA, and it's divided by J. Okay. So this is what you're gonna get in the algorithm. Although I would like to require from you guys to practice this homework as well. Not only this, but these starting from here until the end. So if you want, I can give you the presentation itself in order to practice
Yes, that
with
will be good.
by yourself. Okay.
And can
I'll
you please
give you
explain
the
what's the K? What does the K stand for?
K stands for noise reduction and pixel segmentations.
Ah, okay. Got it.
Yeah, yeah.
Thank you.
Nice. Welcome. So, noise reduction and blur filters. Oh, that's my favorite part. But what do you understand when you say blur filters? I mean, you can see it, of course, you can see it on the picture.
Um, so I think that the low, so no, it's noise reduction. So it means like the lower the number is, the less the noise is reduced. Maybe like this.
Hmm.
So I'll say that maybe A is relating to the picture B.
But it's not.
Okay, it's A is not to B, right?
No. You see, when we have a noise on the original picture, you see, we have small white dots and black dots. We have noise over here.
Yeah.
Well, but it's original picture. You see, it's 111. Everywhere is one, like RGB, like three colors over here. Let's say three colors, RGB,
Okay.
and we have a blur capacity is 1/9. I mean 9/1, right? When we are getting to the, oh, I'm sorry, it's actually this one. I have to explain. So we are getting the blur blur reduction 9/1. So it's kind of it's not the maximum, but you see it's reducing the noise itself.
Yes.
But
The
when we are
quality.
yeah, but we are losing the quality itself. We are losing the noise, but we are losing the quality also. You know what I mean? So it's giving us from the original picture with the noise, it's giving us the one triple ones. I mean, everyone is one. But when we switch to the B, we are getting the blur capacity is 10/1, and we are getting better images. So we are getting a two here. For RGB is black, we are getting the lower black. I mean, like more black. You know what I mean? So when we switch to the C, we are having a blur capacity is 16, but we're not losing the image, though we are getting rid of the noise itself as well. So when we are calculating and coding on the algorithm at the backside, because we are practicing in the back end, right? So we have to know which part we want to use it. So when we're calculating, we can try to use it automated programs like Photoshop or any other filter reductions like blur reduction, filter reduction, a noise vector in order to get the code, numbers out of it. So we're gonna just use numbers out of it. So it's something like when we are calculating, we are using a calculator by itself. Like on our phone or on physical, right? It's different. It's not different from that. We are just using a program in order to get the numbers at the backend. Okay,
Okay.
so we can do that. So noise reduction and solve data noise reduction as well. So why so many noise reduction? Huh? Okay, another region. So its region is growing by method of the unsaid region growing and the methodology of the noise reduction by salt and paper. Okay, so it's modified by algorithm and it does not require explicit. Uh, it seems it gives you something like seeds in stars that in signal region. And if we see original from process after we done it, we still use the salt and paper filters to reduce the noise reduction. Okay, and the pixel chosen here it does not give you a like markedly influenced in final segmentation. At each how can I say each in conservation of the neighboring pixel in the same way of the seeds region is growing, it defines you from seeded region growing and gives you a more clear pixel. Okay, so we are clearing the noise, but we are losing the
Can't.
pixels. But
Okay.
we have to like play around a bit. So over here we use 9 out of 1. 1 out of 9. But over here we use after the process by salted paper, we used 8. So we are getting a 0 at the middle of the RGB segmentation. Okay. So how the Gaussian filter is gonna work? So when you see the algorithm, the Gaussian filter, it's kind of a bit complicated, but I would suggest you guys to recognize the formula itself and the calculation, though it's a bit complicated for me to explain you guys. I have to use another language. But I'm going to practice with it on the next lecture. It's going to be easier for you if I show you guys. Because it's kind of a bit complicated to understand by algorithm itself, but when you're coding, it's going to be easier. So the image segmentation is since then the modeling of the impact of the pixel neighborhood on the given cluster and pixel or pixel itself under this assumption of the hologram and the pixel and the noise itself. Uh, this is kind of a methodology of the pixeling and directly the graph itself. Usually, the pixel or the group of pixels are associated with the nodes and age and weight and defiance of the similarity between the neighbors and pixels. Okay, the certain design form you're gonna use on the backend or to partially backend according to the creation of the design to a model is gonna be a good cluster or each portion of the node is gonna give you a pixel output from the code. Okay, so this is noise reduction median filter. So when we are getting code on median filter, as you can see that we are getting 3 different numbers at the middle of each pixel. So when you see on the left side of the picture itself, we're getting 1 square feet. It's not square feet actually. 1 square. Let's call it as a pixel. But in each pixel, we are getting small numbers. That it's numbers, but when we see it on our computer, it's going to give you a color. But at the background, it's a number. It's just a number. Okay. So who can tell me what does it mean at the middle of the square? It's 150. So what does it mean?
Like what does the number mean?
Yeah. I mean, like, why did I highlight it? I mean, why did I highlight the 150?
Maybe it's like the representation of the brightness of the color, or and maybe the amount of blur.
uh, it's actually, you see on the left side of the picture, we have two pictures, the original and after the processed. So original is, we have noise at the middle of the pixel, which is 150. So you see the rest of the numbers, not more than a 150.
Okay, it's like the
If you
max value.
see, yeah, it's higher. It's kind of black color. It's not related to the rest of the numbers. You see, we got 124, 126, 127, right? And on the next line we have 118 and 150, 125, and so on, so on. But why don't we have 150 or between 140 or 160? Because we you see on the square we are getting not more than the numbers, not more than 127 or 130, but we have 150, which is error, which is it's a noise that we don't need between these colors. So when we process the filter at the bottom, you can see the over here we reduce the noise itself. So until 124, so until it's seamless, but it switched to another place. So it's how the filter is gonna work. So it shifts from one point to another point, but you're still gonna get the noise from one place to another place, but it's gonna be a bit seamless. You know what I mean?
Yes, so it means like it shifts by the diagonal.
Yeah, but it's going to be a bit seamless, but it's going to be blurry. So when you're using a photo editing program, you're blurring it, but you're moving from one pixel to another pixel, but it's going to be at the same place. Still going to be the same place, but it's going to be a bit seamless because we are minusing from here, but we are adding to the rest of it. I mean, like we are adding 115. You see, it's 115 here and 124 here. But we are reducing somewhere, but increasing somewhere. I mean, like we're spreading the 150, the whole thing, until it's reduced to 124. And we are giving the others in order to reduce the noise from one place. I mean, like, um, you have you seen the salt that got at the one place, but uh, when you shake it, it moves from side to side. I mean, like if it's in a square, so it's something like similar to it. Okay, so
Okay.
moving on. Oh, our slide is finished. Oh, have I been talking so much?
No,
I thought
no,
there's
it's not
more.
that much.
No, I thought there's more. So I forgot that I'm almost at the end. So, guys, question and answers. Please give me some questions.
Okay. Um. So this was not the realization of object transforming. It was about colors and mostly about the noise reduction.
Yes, yes. Noise reduction of the pixels. So, how we are gonna, because you see the programming of the C sharp, and all that is for the backend. Like the whole programming language is gonna when you're coding, you are coding at background in order to show or appear it on the front for the users. So when you're coding a single part, uh, you're coding for the users, and you have to know how to bring that pixel to the user. Okay, so you have to know how the noise is going to work if you're getting an error. So last time when you let's just take it as sample. You got the output of the midterm exam, the fifth question. You got so many like numbers.
Yep.
Remember, it's an
Yes.
error, but let's take it as a noise reduction. You got the error over there, but you have a noise, but you have to know how to fix it. You know what I mean? So you are
Yes.
getting 1 to 5 to 15, but you must get not more than 5 to 7. So you have to know how to fix it. So it's kind of how to reduce the noise. I mean, how to fix the noise and how to use the filters of the segmentations. Like over here, I've got mentioned that, what was the name? So image qualification enhancement. You will use the contrast enhancement, noise reduction, and XNX. And it's actually a big topic. It was actually a big topic when I read about it, because there's a believe me, there's like tons of the documents that you have to read about it. It was actually a big topic, but I've tried to minimize it until the end. But if you guys are interested, I can give you the documents and documentations that you can read through. It's actually a huge topic, but I don't know why they have placed it in one day topic. It's kind of really impossible to uh, teach you guys in 1.5 hours. It's not possible. But I have tried to reduce it and try to explain it. So if you have a question and if you want to learn more about it, I can give you the documentation itself about the color enhancement, image processing, 2D image, and noise reduction, and about the image or science analysis by edging and detection, segmentation, and region explanation. And there is more actually. If you guys are interested, I will send you the links, but but not to the group, but in your private message. All right? If you guys
Yeah.
are interested, of course.
No, it'll be actually very like beneficial if we will know this also in the future, I think.
It's okay. If there's gonna be a king on my head, it's gonna be on my shoulders. So I would like you guys to do well on the final exam. But if you want me to send it up to the group, it's okay. I can send you to the group. I have in the file as a
So
file. I
like
mean,
at the exam, I'm sorry to interrupt you again, and so the questions related to the color enhancements and the noise enhancements, or you said noise enhancements, right?
mhm.
Is there gonna be questions at the midterm at the final
Final
exam
exam.
about this?
About this, I'm not really sure, but they might be because when I was doing competency table, they have asked me what topics did I taught you and what topics didn't I, and there were questions. Um, there were questions. Can they draw a Berghamsian line by coding or by themselves or with the help of the teacher, and so on and so on. So it was like there might be everything. There might be. Of course, it's gonna be. There might be. Because that's why they have been asking me what I have taught you, what I haven't taught you. Because I do know that what I've taught you and what I've practiced with you. But I was pretty sure that at least 2 or 3 guys can pass my subject. You and Yunus, maybe, and Kamal. But it was like, I was shocked when I was like, oh, is it really possible that Yunus can fail or Vladimir was doing good? great. But how it's possible? It's kind of almost like a bit disappointed by myself. So, anyways, I will send you the links, and I will give you the files that you can to study before your exams, and I would like you to guys practice a homework. There was a homework for you. Just give me a second. I will give you the homework for you. So, are you guys ready to do a homework, by the way? But if you're not going to do it, I'm not going to give you. I'm not forcing you. It's better for you to practice in the private.
No, it'll be okay if we'll have practice. Just we need, I think, the deadline to be a little bit further away from our. I mean, not further away, like maybe before our lesson, like a day before. I mean, because sometimes it's very hard to understand the way the algorithm works and to tackle through how to write the algorithm itself. And we also have an incomplete homework from the last lecture.
Of course.
So
But you will still gonna have at least 3 days starting from today. But I'm not calculating today's time. You will still have at least 3 days until next our lecture. But you are going to guys have at least 10 or 15 days before your final exam.
no,
So you will still have time to practice or ask any question if you are interested.
okay.
Okay.
And
Okay.
just
I
from the
copied
last.
the. Huh? Come again?
Sorry. I just have some question from this last page. It's like one test.
I don't get you.
From the previous, he has a question from the previous page
No, yes, last page.
Okay.
before the questions and answers. Can you please show the slide next to
Mhm,
yeah.
mhm.
Yes, and the noise it will have if the number will be harder than the number center, yes, or
Can you write your question, please? Because
yes.
I'm sorry.
It's
It was
okay. It's actually
because
a bit
he
difficult.
didn't speak much to me since our first class. He didn't speak much to me, so that's why sometimes it's hard for me to understand him. But if you can speak more and more, maybe it's gonna be easier for me to understand him as well. Right, Yunus? If the number will be higher, the center number of noise. Hmm? Yeah, because when you're coding pixel by pixel, and maybe your picture has a noise in the middle, but you can't see it by pixel, and you have to reduce the number itself in order to lose the pixel, right? So you will not know for sure beforehand that you have a noise, but once you get the error, it's your picture that the pixel itself. Once you get the error, then you will know. So if the number, when you see it, if the number, the three number, I mean three row of the number, if you see it's more than what it is, I mean like in the three rows, for example, we have 1, 2, 3, and 1, 2, 3, like triple 1, 2, 3 is at the three rows, right? And at the middle of it, or somewhere, it's more than three or more than five. So you have to know that you are getting a noise over there. Most probably you will get at the middle of the three square rows. In most cases, but if you see here, we don't have at any row, we don't have more than 130, like 130. We don't have any number. But at the middle, it's highlighted, at the middle we have 150, which is by, if we say RGB color. Let me show you something. Let me open up my maybe Photoshop if I have. Can you see my Photoshop program?
No.
No, right? Hold on. Okay, can you see it now?
Yes.
Yes.
Okay. Let's just say that we have a picture over here. Imagine this is a picture over here. Let me use this. Change the color to blue. Just say it's a picture over here. Okay. And when we are getting, let's say, let's just draw 3 columns. 3 columns. We have 3 columns here. Um, 3 columns here. Oh, sorry for my language. This is our one picture. Remember, I have placed it. Okay. This is my one picture, but I have separated to the pixels. Okay.
Mm-hmm.
Let's just imagine that colors. Let's just imagine that one of the colors over here, you see the RGB, right?
Yes.
You see RGB. Let's imagine that RGB is RGB. Let's imagine this is going to be just our imagination that it's going to be a picture. Let's say R. Okay. Let's just imagine this is our RGB, right? And we have also RGB here. There's all 3 columns, but we are getting similar colors over here. But at the middle, when we see it, we are getting a different noises, something like this. My God, I got something else. Oh, yeah. It's 1 pixel. We are getting similar colors, but at the middle, we are getting a different color, which is a noise. We call it as a noise. So it's a different color and it's an error. Sometimes we get the bug on our code, right? It's the same. When you're seeing, when you're watching to the beautiful picture, but when you see a different color and different dot, it's not belong to it. It's belong that to that place. So it's a bug, but we call it as a noise. You get what I mean? So in order to reduce this, we have to use the filters to reduce the noise itself. Or it's not the light color, but it's a darker color. So this is how we're gonna see the noise. You get what I mean?
Yes,
When we see it in RGB over here, you can you see that we are getting the numbers and the colors of this and the color of the one I used. So it's over here. It's more than 145, but it's not more than 219. So if we are getting RGB and RGB like this, at the middle we are getting the noise. Do you get what I mean? So
yes.
this is how the noise is gonna work.
Yeah.
We are getting the almost the same numbers, not more than each other, but it's we are getting the noise. So for example, let's say it's gonna look something like this. We have it's a picture, right? We have to use it similar colors, right? So if we have a picture and we are using similar colors to it, it's one picture. It's just a one picture that is just we are getting a gradient of the pictures itself, but we still have the noise at the middle. This is how the noise is gonna work. Oh my god, how can be? You see, it's the picture, the container itself is the one picture. It's just the colors at each pixels that we're getting the color, but at the middle of that place, it's not supposed to be at the middle of it. It can be at the corner. It can be somewhere else, but we still have a noise. We still have a bug that we have to fix, and in order to fix it, we're gonna use the filters, the different filter for the different solutions. All right? You get what I mean? So it's similar to it. So this is how the pixel and the noise is gonna work. Is there any questions? Oh, it's been so long that I haven't used this program.
I
Uh,
think no more questions. Just have to look through the presentation again in order to make sure. One, I guess homework. That's it.
okay. I'm gonna forward you the homework, and we're gonna if you can't do it, and if you don't understand it, it's all right. We're gonna practice it on our next class. We still have a time, right? And be patient, keep in touch, and I love you guys, and I'm gonna miss you.
Or if we hopefully will pass the final exam.
I hope so. I wish you can pass it because if you can, guys, pass, you're gonna make my year by end of the year. Because it's almost end of the year, but if you can't pass it, I cannot forgive myself because I spent so much time in order to teach you guys, but
It won't be your fault if we
no, it
won't
won't
pass
be
it.
my fault. But I'm gonna feel it bad because you guys can't pass it. I mean, like, you are good guys, and I wish you that you can go abroad and study and see the world itself because someday you're gonna understand the world and understand the situation. Someday I'm gonna maybe visit you over there. But I've been there, by the way, several times
Oh,
back in 2017. So it's a great place, and I mean, like, I wish you can go faster and see it by yourself. It's a great place, actually. I love it. I've been in Germany this year at the beginning of this year before the quarantine started. So yeah, it's great places and good choice for living and studying. And I wish you guys well in your exam and well in your studies.
thank
All
you.
right. Thank you for your time. Thank you for understanding. Thank you for everything. And please make my year. Please. All right. Keep in touch, cheer up, and all the best for you guys. I'll see you in
Thank
the
you.
next class. Thank you.
Have a nice day.
Have a nice day, you too, and have a nice weekend.
Yeah, thank you. But we have lectures on Sunday.
But still, it's a weekend.
Yeah. Okay. Thank you. Yeah, it doesn't
Thank
change
you.
the.
Bye bye.
Goodbye.
Bye. Have a good day. Bye.
Bye bye. Thank you. Bye bye.